Hi. Hello, I did not see you there. I am Professor DUFENSHAKLENBLOCK, and today I will be teaching you about DNA replication. This message is brought to you by Umbrella Corporation, therefore, watch out. I will teach you the basics to survive an apocalypse, since we are very near. Zombies replicate very quickly, faster than humans. Humans every single, let's say, 3 months, but for like skin cells, 2 days, hours, minutes, seconds. So we have a double helix DNA like that. Yes, that is the original that you have in your body. And your cell decides, okay, let's make more. So this enzyme comes in and starts unzipping and unwinding the DNA. And then you have that. That is what happens, yes. And it moves from 3' to 5' direction. Then after that, this really pretty thingy comes in called RNA primase. Yes. And the RNA primase, as it says, it primes the cell. So it leaves the bases behind. And if you don't know what bases are, you're screwed. Yes. So the DNA primase comes in and it moves in the 3' to 5' direction. This is on the leading strand. We are looking at the leading strand. Do not think this is the lagging strand. Leading strand. Next picture. Oh, that's the previous.
Ingrid,
Yes, Mom.
your breakfast is sitting in the stove. You just have to put it on top of your cheese.
Okay, thank you. That is my mother. Yes. Then the DNA polymerase 3 comes in with the free DNTPs. If you don't know what free DNTP is, it is a nucleotide with 3, not 1, not 2, but 3 phosphates. Yes. Cool. So, the DNA polymerase 3 takes away the primase and it leaves behind the DNTPs, the free DNTPs, the nucleotides, yes. Again, leading strand. Then the DNA polymerase leaves them and they are there. And the DNA polymerase 1, not 3, 1, comes in and it takes away the DNA polymerase 3. Like cleaning its mess, yes. They're like the janitors. And voila! That is the continuous strand. It is the lagging strand that is much harder. The lagging strand, and here we go. You must know, it is in a 5' to 3' direction. Therefore, it is the other way around. It is ridiculous, but yet we have found out that it does. We have not found the reason why cells cannot change, like leaving the 3' to 5'. Who cares? So on the lagging strand, we have the DNA primase coming from a 3' to 5' direction. Therefore, it is the opposite and it takes more time. That is why it is called the lagging strand, because it has to wait until a certain amount of the DNA is open for it to go in and then come back, because it goes from here to here, from here to here, from here to here. Then the DNA polymerase comes in and the DNA primase stops. Yes. The DNA polymerase 3 does the same. It leaves behind the 3 DNTPs. Then the DNA polymerase 1 comes in and takes away the DNA polymerase 3, and the DNA polymerase 3 stops. That is why it's called discontinuous, if you had not known. This process is repeated and repeated and repeated, but not together. That is why we have some fragments called the Okazaki fragments. Why do you name them Okazaki fragments? Just go with it. The researcher was called Okazaki. He was Japanese, yes. Why didn't we discover it before? Well, Russia nuclear reactor in Chernobyl, yeah. And then after that you say, but wait, why? The Okazaki fragments are DNA fragments. We cannot live like that. Of course we can't. So then this little enzyme comes in called ligase. Ligase acts like superglue. And superglue glues Okazaki fragments together and then disappears to leave the perfect DNA replication. And finally, this process is repeated and 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 repeated, and until you cannot say it anymore. Until you have replicated DNA cells with half the original material. And then that process is repeated again, and then you have a quarter, and the same. Half. This message is brought to you by the North Pole. Please make sure you survive the apocalypse. Thank you.